section 10.5 is on source transformations. So we've done these before. I think it was in chapter 4. If we have a voltage source in series with an impedance, we can translate that to a current source in parallel with impedance, and vice versa. We can go back and forth. All right, so let's work an example problem. So use a source transformation to find I. Our resistance 5 is fine. Our current source, we want to write that as 16 angle 30 degrees. Resistor 3 is fine. J omega L, J times our omega is 200. L is 5 milli. So that gives us just J1. I'm just writing it right here. And then minus J over omega C, minus J over 200 times 1 milli. That's messy, but that gives me minus J5. Oh, I don't know if that's a J or a 5. It's like both. Minus J5 ohms. There we go. And I'm crushing my papers. Okay, so I want to do a source transformation. So I have this situation, right? I have a current source in parallel with a resistor, or with an impedance. So I can do the source transformation over here, and I'll get a voltage source in series with the same impedance, happens to just be a 5 ohm resistor. And then everything else on the other side there stays the same. I'm not doing anything to that. So we just draw it all back in there. Minus J5, J1, ohms, 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 current. We need our voltage. V equals the impedance times the current. So we have 16 at an angle 30 times 5. So our voltage is 16 angle of 30 degrees times 5, or that gives us 80 at an angle of 30 degrees volts. All right, current's very easy now. Everything is in series. I equals V over impedance. I equals V over impedance. 80 over 30 divided by all of these in series. 5 plus 3 plus J1 minus J5. And we get 8.94 at an angle of 56.6 degrees amps. We were asked to find lowercase I, meaning they want it in the time domain. So I of t equals 8.94 sine 200t plus 56.6 degrees amps. So that's a source transformation in phasor domain.